freecoachingtoday.com.
So we have already seen how to do the addition of two vectors in the previous lecture. Let's now see the multiplication of a vector by a scalar. So what is, we have a vector A, we denote it as a vector, and we are going to multiply it by a scalar. A scalar is simply a number like 4, 5, 3. A vector has some direction. Let's say this is a vector A vector, and we are multiplying it by a constant k, which may be like 2 or 3. What does it result? The result is another vector. And when this is a vector, we have to define two things: its direction and its magnitude. The direction of B vector is the same as vector A. So B vector will also be pointing in the same direction. And what is its magnitude? The magnitude will be k times A. For example, if k is 2, it will be twice as big. If k is 3, it will be thrice as big. So if it's k is 0.5, it will be half as big. So B vector is a vector which has the same direction as a vector and which has its magnitude k times a vector. Now in particular, if k is equal to -1, then this vector B vector becomes minus a vector. And what is its physical significance? -1 means this vector B vector will have a direction opposite to that of a vector. In the same way, if we multiply it by minus ka, then it will have opposite direction to that of B, and it will be k times in the reverse direction. So that is the multiplication of a vector by a scalar. Another important concept is this, that is the concept of a unit vector. We will see it later on in the context of resolving the vector, but for now, a unit vector, if a vector is pointing in this direction, then a unit vector is a vector of unit magnitude pointing in the direction of a. For example, if I call it, let's say, k vector, a unit vector is usually denoted like x vector. Then x vector is a unit vector. It has the same direction as the a vector, and it has the unit magnitude. So what we do is we divide this a vector by the magnitude of a vector. We note that a vector is represented by a vector, and a vector's magnitude is represented by these two bars around this vector. Now we will also talk about, let's say, subtraction of vectors. So we will work on subtraction of two vectors, but the same concept we can apply in case of more vector. So let's say we have one vector a vector, and we want to subtract this vector b from a vector. So what do we do? To add this vector, we use triangle law. We just extended this b vector here and we added it like this. What to do when we subtract from a this b vector? So we draw this a vector and we have this b vector. The first thing we do is we reverse the direction of b, and we draw a vector which has the same magnitude of b, and in the reverse direction we get minus b vector. Now we have to add a vector with minus b vector. The law is the same. You displace this vector so that its tail is pointing to the tip of a, and this is minus b vector. We just add a vector and b vector, we will get the resultant vector b. Let's take an example. Let's see, we have two